question 7.4, you have a voltage source of 40 volt and a resistance of 2 ohm and a switch that opens at t equal to 1, t equal to 0, a resistor, a 12 ohm resistor, a 4 ohm resistor, a 16 ohm resistor, and a 2 Henry inductor. I of t flows through the inductor, current I of t. You'll have to find I of t when t is greater than 0. So first, you know the equation. We know the equation for first order current, I guess. I of t would be the initial current, I of 0, e to the minus t by tau, where tau is the inductance by the equivalent resistance of the circuit. You have to find out the initial current and the equivalent resistance. First, to find the initial current, you have to find this is the circuit when t is less than 0. That would be the initial state of the circuit. In the initial state, the inductor acts as a closed loop. So there's a short circuit between the terminals of the inductor. That means that the 16 ohm resistor is not in the circuit anymore. It doesn't matter. So this is the equivalent circuit you get. So to calculate I of t that flows through the inductor, you assume there's a current flowing, current I1 flowing through the 2 ohm resistor that gets split between the 4 ohm resistor and this 12 ohm resistor, one of which is I of t. So you have a current I1 that divides between two resistors. You apply current divider rule. So I of t would be the other resistor 12 plus the sum of both the resistors 12 plus 4 multiplied by the source current I1. Now you have to find out I1. To find out I1, you can combine the all the resistors. These two resistors for 12 and 16 ohm resistors, they both are in parallel. So you get a 3 ohm resistor and a 2 ohm resistor in series and a 40 volt power supply. So you have current I1 flowing through two resistors. You can apply current divider rule. You can just combine the 2 ohm resistor and the 3 ohm resistor and apply I is equal to V by R. Voltage is 40 and the resistance is 2 plus 3. They both are in series. So you get I1 as 8 ampere. Substituted in this equation, you get I of t as 6 amps. So that's the current when t is less than 0. In an inductor, the current cannot change instantaneously. The voltage can, but the current can't. In a capacitor, the voltage cannot change instantaneously, but the current can. So you have I of 0 minus, that's 6 amperes. Since the voltage can't change immediately, the I of 0 also would be 6 amps. So you have the initial current, that's 6 amperes. Now you have to find out tau. Tau is L by R equivalent, resistance, equivalent resistance. To find out equivalent resistance, you assume time is greater than 0. When time is greater than 0, the switch is open. So only this part of the circuit is operational. So you have 4 ohm resistor in series with the 12 ohm resistor. They both are in parallel with the 16 ohm resistor. So you get the equivalent resistance is 8 ohm. So tau becomes 2 ohm inductance divided by the 8 ohm equivalent resistance to get 1 by 4 seconds. You substitute both the initial current of 6 amperes and the time constant 1 by 4 in this equation. You get I of t as 6 e to the minus 4 t ampere.